Today's video, here is a nice problem that was suggested by viewer. Here is the following information. We have a, b and c as integer numbers. We have these following two equations. We have the sum of these integers a plus b plus c equals number 6. Then the product of these integers equals 8. Okay, so in fact this is not hard problem. Just you may solve this one quickly if using the shortcut, or you can make it a little longer. You may solve it in such ways which takes you a little longer, but it's nice method. Okay, so you guys, you can give it a try to spam pre-get to the solution. Go ahead, pause this video when you want to come back to see the first solution. Okay, now let's jump into the solution. The second thing, we have the symmetry everywhere. Okay, because integers a, b and c are playing the same role here. Okay, so let's go through this way without loss of generality. We assume a is inferior to b and b is inferior to c. Okay, first of all, I'm going to check where we have equality. Okay, if a equals b equals c, I'm simply going to plug the a into this equation to find a, b and c. So I get here 3a equals 6, so equivalent equals 2. So which means I have the following solution. I have a equals 2 equals b equals 2 and c equals 2. So if you plug this one into the second equation, you get the same thing. You get a is multiplied by 2 is multiplied by 2 is given as 8. Okay, so this is the first solution when we have equality. All these integers are equal to each other. This is one thing. The second thing, if you take a look at both equations, since we are working on integer, so the ABC could be positive, it could be negative. But by combining these two equations, we are going to check where we have the negative numbers. Okay, for the first equation, we cannot recognize where we have a positive or negative, because you could have one number negative, the other positive, you still get number 6 here. You can have both numbers positive, the other one negative, you can still have the same number 6. So it's hard to find out where we have the negative and positive number here. But if you take a look at the second equation, we have a clear image where we have negative numbers. So you can have two cases. We can have two possibilities here. The first possibility, you can have all these integers are positive, is giving you arithmetic number 8 here. But the second case, you must have two integers negative in order to get a positive number here, because negative is multiplied by negative is given as positive, is multiplied by positive, we still have the positive number. But if one of these negative, this one it becomes negative. Okay, or three of them negative becomes negative, which means we are going to take two cases. When we have the two numbers negative, we have two numbers positive. Which one will be negative here, which means positive? Since we have this error, I'm working on this direction, smaller than b, b smaller than c, we are going to assume a and b are the negative integers. Okay, I'm going to assume this one is strictly inferior than c, because we don't know. Maybe we have because we may have one case a equals b here, we don't know yet, but this one is clearly strictly inferior than c. Okay, we are going to prove this one later. So for now, the case number 1, if a is strictly inferior than 0 and b strictly inferior than 0, okay, but c strictly superior than 0, as we explained just now. Okay, so if this one strictly inferior than 0, b strictly inferior than 0, so which means a is inferior to -1 and b is inferior to -1. Okay, with c superior to number 1. Okay, since if one number 1 to be included here, we are going to push this one in and put the superior or equal sign. Okay, what I'm going to do now, next thing up, we are going to take another two sub cases here. Sub case number 1, a equals b equals -1. Okay, if we have equality on negative numbers, let's see what's given us. Okay, so I'm simply going to replace this information into both equations to see what's given us. I get here -1, which is -2, plus c equals 6. This one is telling us c equals 8 by taking -1 to the right. Then I'm going to, for verification purposes, we are going to check this value of C is satisfied this equation or no. Okay, so we know A equals B equals -1. If we plug in -1 is multiplied by -1 is given as number 1. 1 is multiplied by 8 is given as 8, which means this value of C, it's the right value. Okay, so which means we have the following solutions. So I'm going to write the solution, to put this solution here. I get here the first solution, A equals -1, B equals -1, with C equals 8. But be careful here. We are going to put the 3 copies of this one because we have a nice symmetry here. Okay. Second solution, I get A equals -1, but B equals 8, and C equals -1. Both cases are working here. The last solution, I get A equals 8, but B equals -1, C equals -1, like this. If you plug all these solutions in both equations are satisfied, these solutions. So I have done with this one. So I'm going to add that solution right there over here. So the first solution was A equals 2, and B equals 2, and C equals 2. Let's check the subcase number 2. Subcase number 2, I'm going to make the change in A here. Okay, I'm going to make a small change in here. I'm going to put A, if A equals -2 and B equals -1. So what I have changed here, I'm just making another case when you have A equals -2 and B equals -1. You may have any solution. Since we have A is inferior to B, so I'm going to take this following case after this one. You may have solution right after these numbers, because I'm just grounding A with one more number down, and I left B as it is. Okay, so I'm simply going to take these both values and insert them into the original equation to see what's given us. So I get here -2, -1 plus C equals 6 equivalent. I get C equals 6 by moving these two numbers to the right. I get 6 plus 3, which is 7. We know A equals -2, we know B equals -1, we know C equals 7. I get here -2 is multiplied by -1, which is 2, is multiplied by 7, which is 14. 14 is different than 8, which is impossible, which means we have no solutions in this case. Now let's consider the following case. Now let's take the general case. If A is inferior to -2 and B is inferior to -2. Okay, now we clearly understand why I'm working on this interval, because we don't know the previous case when we have A equals -2 and B equals -1. We may have a solution. We checked that, we found no solutions. That means we are free to work on this interval now. Okay, now let's take it as a general proof. If A is inferior to -2 and B equals -2, I'm going to sum these two integers. If I'm putting A plus B is giving us -2, which is -4. Okay, then by adding C on both sides, I get A plus B plus C is inferior to -4 plus C. We need this term equals 6. Okay, by taking this -4 to the left, I get 6 plus 4, which is 10. 10 is inferior to C. Okay, I'm going to pick up this fact and use it in the second equation. Okay, so we know A is inferior to -2 and B is inferior to -2. I'm going to make the product of this one is giving us A is multiplied by B is superior to 4, because both of them are negative. Okay, then I'm multiplying both sides by C. I get A, B, C is superior to 4C. Okay, then I'm switching the order of this one, so this one is giving us C is superior to 10. Okay, then I'm multiplying both sides by 4. I get here 40. Okay, because this one, it was 4 is multiplied by 10. Okay, which means 4C is superior to 40. We know this value of this product, which equals 8, is given as 8 is superior to 40, which is it's clearly a contradiction. Okay, which is impossible to find a is superior to 40. Okay. Now we have no solutions. We have no solutions on this interval. Now let's move on to the next case, case number 2, which is when we have all of these integers are positive. I'm going to read this board and move on to that case. So previously we were working on the case when we have both numbers negative, and we found the following solutions. Now we are ready to work on this condition. Okay, when we have all integers are positive. This one, it's very clear here. If you take a look carefully as we follow, no equality here. So equality is already gone. Now I get A is strictly inferior than B and B is strictly inferior than C. So by using this condition, A is strictly inferior than B, B is strictly inferior than C. This one is telling us A plus B plus C is strictly inferior than 3C. Okay, because A is strictly inferior than C. If you add in number B on it, you get B strictly inferior than C, which is 2C. Then by adding C on both sides, you get this sum. So this one is already, you have the value of that one right here, which is 6. By dividing both sides by number 3, I get 2 is strictly inferior than C. I'm going to keep this condition. This is just half of this inequality. I'm going to find another half. So since all this positive, since A is strictly inferior than 0, and B is strictly inferior than 0, and C is strictly inferior than 0, this one is telling us taking this value of C and insert it in both equations. I get E plus B plus 3 equals 6 is equivalent. A plus B equals 3 by taking number 3 to the right. Okay, taking this value of C and insert it into the second equation, I get the following. I get 3AB equals 8. Okay, also I'm going to take the value of B and insert it into this equation to have a new equation in terms of A. Okay, I get 3A is multiplied by 3 minus A equals 8. Okay, then distributing this one out, I get 9A minus 3A squared equals 8. Okay, then moving over this term to the right and bring 8 over to the left, I get 9A minus 8 equals 3A squared. Dividing both sides by number 3, I get 3A minus 8 over 3 equals 8 squared. Okay, we know this one is an integer. Of course, it's a positive integer, which means this one also is an integer, but this one is not an integer. Okay, which it's clearly it's a contradiction, which means this is a ruled out of this possibility. Okay, let's check another case. If C equals 4, by doing the same thing, inserting number 4 into the first equation, I get E plus B plus 4 equals 6, equivalent. A plus B equals 2, because by bringing number 4 to the right, I get this result. A plus B equals 2. Okay, then extracting out the value of B from this equation, I get B equals 2 minus A. Then taking the advantage of this value and plug it into the second equation to see what's the new expression is. Okay, so also at the same time replacing number 4 into the second equation, I get 4 times E. 4 times A is multiplied by B, which is this value, which is 2 minus A equals 8. Okay, and dividing both sides by number 4, I take this 4 out of here, I get number 2 here. Okay, so if you take a look at both terms, if you take a look at the left hand side of this equation, this term is strictly inferior than a. Okay, since this value, since this term 0 is strictly inferior than 2 minus a, strictly inferior than a. Okay, which means this one is taking the small value, this one is taking the big value. By using this condition, a must be equals 2, but 2 minus a must take in number 1. Okay, plug in number 2 into this one, I get here 2 minus 2 equals 0, which equals 1. It's clearly a contradiction also, because we found 0 equals 1. Okay, let's move on to the last case. Okay, the last case, if c equals 5, taking this value of c and insert it in both equations, I get a plus b plus 5 equals 6. Equivalent a plus b equals 1. By taking number 5, after taking number 5 to the right, I get this expression as a result. Okay, then the second fact, I get replaced c with number 5. I get 5 is multiplied by a. b will be replaced with b equals 1 minus a. By taking this, the value of a to the right, I get that result right there. Okay, so which means I get 1 minus a is multiplied by 5a equals 8. Okay, I'm going to distribute this one out. I get 5a minus 5a squared equals 8. Okay, if I'm going to use the congruence notion here, it will be more easier to prove this one. Okay, so I'm going to reduce this one to mod 5, since we have 5 as a common multiplier on the left hand side of this equation. Okay, so this 8 is the same as 5 plus 3. Okay, I'm going to make the comparison remainder with a remainder. Okay, I'm going to make the comparison and remainder for each side of this equation. So by reducing this one to mod 5, I get 0 minus 0 is a congruent to 0 plus 3 mod 5 is a congruent 3 mod 5. By taking number 3 to the left, I get minus 3 is a congruent to 0 mod 5. This one is telling us 5 divides 3, which is clearly it's a contradiction. Okay, because 5 cannot divide 3. Okay, we have proven all the cases and we found we have no solutions besides these solutions. Okay, so I have ended this video. If you have any additional method, just post it in comment section below. By the way, don't forget to support us with a like and subscribe. Thank you for watching. I will see you next video. Bye.